Good morning, my fellow scientists. It is Thursday, April 6th, 2017, and I want to talk to you more about lithium. So lithium is a relatively rare element in the Earth's crust, but the Earth's crust is very, very big. So I got a comment the other day on my sodium-ion battery saying that I shouldn't be propagating the myth that there's not enough lithium. The Earth's crust is so big, there's plenty of lithium for anything. And that's true. There's lots of lithium that exists, and I shouldn't be saying that there's somehow not enough for human activities. There is enough. The question is there enough to make the price viable for the applications that we want? So if you look at the total volume of lithium, yeah, plenty of lithium. But if we look at the available reserves right now at current prices and technology, there's enough for all the cars we want to build, but there's probably not enough for cars plus grid storage. Now, reserves is not the same thing as total abundance in the Earth's crust. Reserves is a small set of that, and as prices rise, the reserves grow to be a bigger share of the total lithium that exists. What that means is that prices can go up, and that makes it possible to get more lithium. But if prices go up, that makes the batteries we're trying to build less competitive than other technologies, especially technologies like coal and natural gas that are super cheap. So right now, with current lithium prices, current lithium battery prices, and current solar prices, it's almost profitable to store solar energy during the day to sell back to the grid at night. Prices are probably going to come down, and that will start to become profitable, which is awesome. It's a renewable resource that can last forever. It's jobs as we build out that kind of system, and on top of that, it's a non-polluting source. Brilliant, perfect. But if we start building these absolutely huge terawatt-hour style batteries, then we're going to bid the price up, and then it won't be sustainable. It won't be cost-effective anymore. So in that sense, the low abundance of lithium is going to kill projects like that, because there's always going to be this feedback where we start to make profitable batteries and that bids the price up and it makes them not profitable anymore. So given that, what things could we use instead of lithium that won't suffer from this kind of problem? The answer is sodium, maybe. But again, sodium, as I talked about yesterday, suffers from other issues, such as the fact that it's still really expensive to produce a sodium-ion battery, and the technical problems haven't been fully solved yet. The other option that I suggest might be worth exploring is iron. So iron is super abundant. There's so much iron, it makes really crummy batteries that have really low performance, but for a grid-tied stationary battery, that might be okay. And in that case, the demand doesn't affect the price so much because we just produce so much iron as a economy. So anyway, thoughts on abundance and price. Things get really complicated when you start talking about economics of energy as well as the chemistry of energy, but stay tuned tomorrow. We'll show you more about iron batteries and our prototypes and the kind of results we're getting here in the Allen Lab.